Hello, I am Mujibur Rahman. I'm a master's student in the Department of Biosystem Engineering at the University of Manitoba. I'm currently working with Dr. Rahman in the Soil and Water Engineering Lab. Today, I'm going to talk about sustainable irrigation water management using a plant control atmometer. So, agriculture is heavily reliant on irrigation, while irrigated land accounts for around 20% of the world farmed area. And approximately 40% of the crop production. In the last few decades, the growing demand for agricultural goods, increasing strain on the world's freshwater supplies, which frequently leading to an unsustainable use of water. While from the farmer point of view, irrigation is sustainable when it is provided uninterrupted access to water resources at a price that not exceeding the marginal revenue. So irrigation is sustainable if it doesn't diminish water like freshwater supplies or impact the environmental flows. So can we achieve sustainability in irrigation? Some of the solutions are that we can do that by minimizing the over irrigation or seepage from the canals or minimizing waterlogging and salinization of the soil. In order to do so while maintaining a good yield, we must properly estimate crop water needs and limit the over irrigation. To do this, we are developing a plant control atmometer that will not only properly predict irrigation requirement in the field, but also helps the farmer to decide the right time for the right amount of water to be applied in the field. So what is an atmometer? So atmometer is a scientific device that is used to figure out how much water is evaporated from a moist surface into the air. So generally, the evaporation rate from the atmometer is used to predict the ET of the plant using crop coefficient, assuming a well watered condition. However, the ET of the plant declined with a declining soil water content, which is not taken into account by the traditional atmometers. The traditional atmometers ignore soil limiting phase of crop ET. That means that it doesn't account for the reduction of ET if the soil is dry and the plant is not transferring at a maximum rate, as you can see in the figures. Because of this reason, the existing atmometer are not reliable in predicting ET since the correlation is about 70%, which means that there is a chance of 30% water loss due to the inaccurate estimation of crop water requirement. To minimize this loss, we need an accurate plant control atmometer. As you can see in the figure, three comparable systems are built and tested under the same atmospheric condition, and it was found that there is an inverse relationship between evaporation rate and suction levels. It was observed that the evaporation rate was significantly higher with a lower negative pressure head, and the rate of evaporation can be controlled by adjusting the back pressure, which mimic the soil water content. Finally, we will be able to figure out exactly how much water each field need. This will help us to minimize the over irrigation in the field to a large extent. Thank you.